ARP table. ARP is actually a protocol that is used to look for MAC address. Yeah, you send a broker message, a unicast message, or a broadcast message, or multicast message to look for IP address of the destination. To look for MAC address of the destination where the packet is going. That is the function of ARP. This layer 1 is the physical connection. Is the physical connection of cables to your system, and then this layer 2 is the Ethernet header. Is the Ethernet header to your, maybe you're sending a frame. After you connect your cable to your system, the message you type, it encapsulates it into a header. Then this layer 3, which is the IP address header, source IP. You can see that the source IP is 192.168.1.1, and the destination IP is 8.8.8, which is the Cisco server IP. If you check this Cisco server IP now, this is the IP. This is destination IP. And then this layer is actually the network layer. This layer 3 is the network layer, which is actually responsible for routing IP. Then this layer 4, which is the TCP, the transport layer, this is where you use your ports, the TCP. You can see that the TCP source port is 1025, which is this system port, because we say that the port that is used by users actually start from 1024. You can see that this port now, this TCP now, this layer 4 now actually carry the TCP because it's sending an oriented message, because we're actually requesting for HTTP. We are requesting for cisco.com, and we're actually using HTTP. And the destination port is port 80. Why is port 80? Is that we're using a HTTP, not HTTPS. We are using a HTTP, not HTTPS. Then the layer 7, you can see the HTTP client make a connection to the server. The HTTP client make a connection to the server. Now let's go back to our notes. Now, in recap of what I said earlier, that the physical layer is actually used to send an application message. It's provided to the user directly. Then the presentation layer is used to encrypt your data by the WhatsApp server. Then the session layer, which is the layer 5, establish and manage and terminate communication session, which actually keep the session on. Then the layer 4, which is the transport layer, is here that the thing will split the message, the packet you send, it will split it into segments. And the segments is actually going to use either TCP or UDP to deliver your message. And the layer 3 here is using, which is the network layer, this is where the routing protocol actually comes in, whereby it uses the IP address to send message when you try to connect your Wi-Fi via radio connection. After inserting your password to it, the router actually learns the MAC address there for the data link. Yeah, that is just what layer 2 does. Now, let's go to the TCP/IP model. The TCP/IP model is a practical network model used in the internet. It contains 4 layers. Yeah, I mentioned something earlier that application layer in TCP/IP model is actually compressed into the layer 5, layer 6 is being compressed into application layer in TCP/IP model. Yeah, combine OSI model presentation and session layer together. Example is the HTTP, HTTPS, DNS, SMTP, FTP, FTP. Then transport layer uses the same thing that transport layer does in OSI model is the same thing that it does in this TCP/IP model. Then the internet layer in TCP/IP model will have 4. Yeah, we'll have the network access layer, the internet layer, the transport layer, and the TCP/IP model. Now, note that this network access layer actually handles the physical transmission. It actually handles the first layer and the second layer. It combined them to the third. It combined them together. The physical and the second layer. It combined the two together. That in this TCP/IP, it combined the two together. And then the internet, it just is the same thing as networking layer in the OSI model. Is it the same thing? It uses IP address and routing. Example, router forward packet across the internet. Yeah, that's what the internet layer does in TCP/IP model. And then if you want to remember the acronyms for this OSI model, is actually written as all people seems to need data processing, which this all stands for application. These people stand for presentation. This seems stand for session. These two stands for transport. This needs stand for networking. Data stand for data link. Then processing stand for physical physical layer. Now let me demonstrate this using a WireShack for you to understand it very well. Let me demonstrate this using WireShack instead of using a packet tracer. Sorry. You guys can still see my screen.
Yes, sir.
Okay. So I've actually captured some data here. So by next week, we'll actually start our practical class. We'll start with WireShack. So, but when we get there, we'll explain all this, how to capture data, how to stop data, all this interface. I will explain everything for you guys. But now let's just explain the the TCP/IP model here. Let's explain the TCP/IP model here. Now let's just go to one packet and analyze it. Let's go to one packet and analyze it. Now, you can see that. Can you guys see it very well? Can you guys see my screen very well? Is it clear?
I can see, but it's
Okay. Now you can see that this frame, this is the Ethernet part of it. Now, the data is being captured from Ethernet 0. We will explain that in our practical class. This Ethernet 0, because in WireShack you have a lot of interface where you capture your data from. Then you can see that encapsulation, this data being captured, this is a live packet. This is a live packet, a real life packet. Now, this is an interface ID Ethernet 0 where the data is being captured. Okay, wait, before I even start, you can see that we have a frame. This frame is actually the data link in the OSI model. This is a frame, the Ethernet. This frame, this is the data link, this is the Ethernet, which actually comprises the MAC address, the destination and the source MAC address. Then this Ethernet here, this is where we use the port and the IP address. This is where we see the port number and the IP address. And then this transmission protocol, this is where you see the protocol being used to transfer the packets, either it's TCP or UDP. Then here we see the application being used to communicate. Which application is being used? Is it SMTP? Is it HTTP? Is it HTTPS? Is it FTP? And so on. So let's start with this frame. Now, look at this frame now. Look at the frame. The frame packet is 1104 packets. Then the packet is 32 bits unwired. Because it's actually seen, it saw it as wired because I'm actually connected to Wi-Fi, but your Michael Linux is seeing it as Ethernet connection, and Ethernet connection is wired connection. So he's seeing it as wired connection. And the bit being transferred here, so let me increase this. Look at the bit being transferred, 32 bit, the total amount of packet being captured. This frame is total amount total packet being captured. Now let's talk about the Ethernet 2. You can see that this is the source MAC address. This is source MAC address. This is my, if I check now, this is my system MAC address or the Linux MAC address. Look at it. Then this is destination MAC address, the server of where I visited, the application I visited. This is the MAC address being assigned to it, or the router that actually permits me to visit the website, the server. This is the server MAC address. Then look at the destination. Sorry. Yeah, this is the destination. This is the destination MAC address, which is actually the same thing we here. Then this is the source MAC address, which is actually the same thing here. Then if you look at this internet here, the internet protocol being used, the IP address being used is actually version 4. That's why you see the root version 4 here. The internet protocol version 4. Yeah, that is the internet, that is the IP version 4. Then the source IP, this is the source IP. That is my device source IP. You can see it from this place that this is the source IP, and it's the same thing with this one. That is 34.107.221.8. That is destination, I mean the source IP address. That is the source IP address. That is the IP address of my Kalininos when I'm trying to send message to this server. And this is the destination IP address of it. This is destination IP address of it. Sorry, I made a mistake here. Sorry. This is actually where I'm actually supposed to. Now, this is where I'm actually need to start from, because the communication actually start from here. This is my source IP address. I'm asking this, I'm requesting HTTP request from this server. This is my source, this is my MAC address. I'm sending message from my source, my MAC address, to this destination address. Then this destination address actually reply. The destination IP address actually changed to the source IP address, because the message I sent is actually replying back to me. And the reply is coming as, when the reply is coming back to me, the destination MAC address will change to the source MAC address, because it's coming from the server to me. Then the destination IP address will change to my own IP address, because the reply of the message I send is coming back to me, and the server sending this back to me will see my IP address as a destination IP address. Now let's check it back here. This is the MAC address, then the internet protocol address. You can see the internet protocol version 4. This is the source MAC address, which is my own IP address of this Kalininos. This is my own IP address of this Kalininos. Then the destination, the server I visited, this is their MAC address. This is the server I visited here. Then this version equals 4, which means this IP address is version 4 IP address, which is the version 4 IP address. Don't worry about all these headers and all these things. Don't worry about them. Then let's now go to the protocol. Let's go to the protocol. You can see the transmission control protocol, which is the TCP. The protocol being used here is the TCP, which is the layer 4. Yeah, the TCP. Then the source port being used, which is my own Kalinos port, is 56,234, which is my own source port. Then the destination port is 80. If you remember, the protocol being visited here is HTTP, and the port number of HTTP is 80. Then look at the source port. Look at it here. The destination port 80. This string packet number 4 means version 4 IP address. Then the TCP segment. So now look at the application layer here. This application layer. This application layer here, which is the HTTP, Hypertext Transfer Protocol. Hypertext Transfer Protocol. Look at it here. We get successful text via HTTP. This is the HTTP gets successful. It's been successful. That is the message we send. They get it where and they actually reply. If you check this second packet here now, and you check the request here, you check the HTTP, you can see the response version HTTP1, HP transfer protocol. Look at it, the response version HTTP1. You can see response version HTTP1 status code. Look at the status code 200. Don't worry about all these status code, all these server, all these number. Don't worry about them. I just want you to just know how the TCP/IP model works. Immediately you send message online. This is how it works This is how it capture it. This is how your message actually works from the frame, from the Ethernet.